Hi, today we are going to solve this integral. And first of all, we need to do a substitution. Well, our substitution will look like this: x plus a, and actually to the power, write like this, 1 divided by 6 will be equal to t. From here, we can obtain that x plus a equals to t to the power of 6. And this part, x plus a to the power of 1 divided by 3, will be equal to, from here, will be equal to t squared. Also, when we use substitution, we need to substitute all our lines with x's and dx too. And now, from here, we can obtain our dx. So, let's do it. d of x plus a, where a is some number, will be equal to d of t to the power of 6. From here, we obtain that dx equals to derivative of t to the power of 6 gives us 6t to the power of 5 and dt. So we have now dx. We have also from here, if we needed x, it will be t to the power of 6 minus a, and we have these and these roots. So now we can do our substitution, and what we will obtain: x plus a to the power of 1 divided by 6 equals to t minus 1. Then x plus a equals to t to the power 6. Then we have 1 plus t squared. So, and of course dx, which equals to 6 multiplied by t to the power of 5 and dt. So now we can, well, we can delete these, subtract 6, 5, and obtain here t, and rewrite it like this: integral t minus 1 in our numerator, 6 I will put here, and here we have t, and t squared plus 1 dt. And now we will integrate this function y partial fractions. So we have a fraction t minus 1 divided by this denominator, which we can represent like sum of other fractions. So let's do it. I think I will take another color, and, well, what we will obtain: not this one, but this one. T minus 1 divided by t squared plus 1. We can write it like sum of a, it's a number, divided by t, plus b multiplied by x plus c, where b, c also some numbers, and t squared plus 1 here. And, of course, from here we obtain this line a. We need to multiply by t squared plus 1, and bx plus c, we need to multiply by t to have here the same denominator like here. And we can see that this denominator and this denominator, they are equal. So we have an equation that means that t minus 1, this numerator, equals to a multiplied by t squared plus a plus b. Here not x, I'm so sorry, of course we substituted our x's, it is t. So b t squared plus ct. And now let's rewrite it just a little bit more. T squared, from here and here we will obtain a plus b, then c multiplied by t and plus a. So we know that this part and this part are equal. So let's see. Here we have no t squared. That means that here t squared multiplied by 0, or we should let our line a plus b equal to 0. Then t. Here we have t and here we have c multiplied by t. And what is our c? Of course it is 1. Here we have 1 and here we have 1. And then a. Here we have minus 1. So here our number also equals to minus 1. Then we have this situation. A plus b equals to 0. C equals to 1 and a equals to minus 1. If a, and of course it's a system, if a equals to minus 1, here we can put minus 1, it will be minus 1 plus b equal to 0, so b will be 1. We have b, we have a, we have c. So we can now rewrite this line like this: a divided by t minus 1 divided by t plus bt plus c. B and c are ones. So it will be t plus 1 here, and here will be t squared plus 1. So this fraction is the sum of this one and this one. Now we can move to our integral here and rewrite it to the sum of two integrals. So we know that all this line equals to this sum. So we can write it like the sum of two integrals. It will be minus goes here, then dt divided by t. Also, then we have 6 from here, 6 multiplied by integral t plus 1, and here will be t squared plus 1 dt. Now we have our two integrals. So this one is very simple, it's logarithm. And what we should do here, actually we can split it into two integrals. So let's do it. I will use the color here. So now I talk only about this integral. We can see that it is 6 multiplied by t divided by t squared plus 1 dt. It's an arrow, a little bit smaller. So now 6 multiplied by integral 1 divided by t squared plus 1 dt. We can see that this integral gives us our tangent. And what we should do here? here we can put our t in this place, and it will be t squared. But if we then have a derivative of t squared, we here have 2t. So we can see that from 6, we will obtain 3 multiplied by 2, and this 2t goes here, and we obtain 3 integrals of the t squared, and we can put here plus 1 because it's constant, and t squared plus 1 here. As a result, we have this integral, this one, and this one. 3 integrals. So let's calculate the final answer. -6 logarithm of absolute value of t plus, from here we have this one plus this one. This one gives us 3 logarithm of t squared plus 1. Actually, it's a positive number. And then we have this one. But we can write a formula: dx x squared plus a squared, and this integral will be very easy to do. 1 divided by a arctangent, x divided by a, and plus constant. A here is 1, so, and x is t. So we have plus 6, then 1 divided by a, 1 divided by 1, and equals to 1, then arctangent, x divided by a, here will be t, divided by 1 plus constant. So this is the answer, but not the final one, because we need to use this line and write our answer with x's. So let's rewrite it. -6 logarithm of x plus a square root plus 3 logarithm t squared plus a. Here 3 because here we have 2 plus 1 plus 6 arctangent of t x plus a, and here also 6, and plus constant from real numbers. So this line is the final answer, the final result for our integral here.